Okay, today we're going to be isolating terms in formulas. And we'll indicate which term we want to isolate over here across from the semicolon. So we want to isolate this formula, missing the A, for R. So let me map out the task here. We have a multiplying 4 multiplying pi that we get rid of, and we have a second power here. So there's a total of 3 things, 1, 2, 3 things we need to get rid of. So the R is by itself. Since both of these are multiplying together, get rid of these 2 at the same time, making this one step, and this will be the second step. So let's preserve the integrity of the original problem. And what we have here, we'll get rid of the multiplying 4 and 5. So we're going to use a dividing 4 and 5. Over here, a dividing 4 and 5. From there, this becomes A over 4 and 5. These 2 cancel. We end up with R to the second power. Now, let's see. Let's over here. Okay, now it's time to get rid of the second power. What I'm going to do on both sides, I'm going to put a root over here. So I'm going to repeat this problem. So you can kind of see the root develop. So I'm preserving the integrity of this problem right here. And I'll come back to this. Okay. All right, so preserving the integrity of this problem, I'm going to get rid of the the root by using a square root. Now, square roots, I'm going to put a 2 here, indicating that this is a square root. It is an understood 2, but I'm putting there anyway, so you can actually see that this is canceling out this power here. So what we do on one side, we do on the other. And so what we get is that the root cancels out the power. We're left with just the R. On this side, we have the square root of A divided by 4 and pi. Next, let's see here. That's there. I still want to use the board here. Okay. Okay. Right, this one. Okay. Preserving the integrity of the original problem here. A equals little a plus little 3 plus little c, all of 3. And we're solving for the A here. So there are 3 things we need to get rid of. It's adding B, the adding C, and the dividing 3. The one I'm going to get rid of first is the dividing 3. Because the dividing 3, this little line here, the technical name for that is vinculum, means that all this is being held together. And so until this line is gone, all this is locked together. So we're going to get rid of the multiplying 3. So I'm going to, get rid of the dividing 3. So we're going to use a multiplying 3 on this side and a multiplying 3 on the other side. So the multiplying 3 and the dividing 3 cancel. And you're left with the A plus B plus C. Over here, 3 times A is 3A. Okay. Now we want to get rid of the adding B and then the adding C. So to get rid of the adding B, put a subtracting B here and subtracting B there. Okay. So kind of step by step. So 3A and a minus B, these cannot be put together because these are not like terms. So we put them next to each other, 3A and the subtracting B, the A plus C. Okay, now we want to get rid of this adding C, so the A will be by itself.
Remember you taught me this.
So we'll subtracting C here, subtracting C here. These 3 are not like terms, so we're going to put them all next to each other. So 3a, the minus b, the minus c, and the a, c is canceled. And here we've isolated a. Okay. Number 3, again, preserving the integrity of the original problem. A equals k, b plus c. And I'm solving for the b here. The b, once again, is locked into a parenthesis. So it's locked, we can't get to it in order to get rid of the adding c. We also have a multiplying k here, out here. So what we want to get rid of first is the multiplying k. Then once the multiplying k is gone, the parentheses will be gone, and then we can get to the adding c. So how to get rid of the multiplying k? Use a dividing k. So what we get is a over k equals k is canceled, and we get b plus c. Now I'm going to get rid of the adding c by putting a subtracting c. We'll go on one side, we'll go on the other. Now, this is a term and this is a term. They cannot be combined because they're not like. So we'll put them next to each other. So we have the a over k minus c equals b, and b is canceled. And we've isolated the b. Okay, number 4. We have lots of stuff to get rid of in order to get the b. We have a multiplying k, we have a multiplying 2, and we have an adding 3c term. So we have to get rid of all 3 of these. Now, nothing inside we can deal with first because multiplying k has a parenthesis around everything. Everything inside there is locked right now. So let's get rid of the multiplying k, so that'll get rid of the lock on this. So, preserving the integrity of the original problem, we're going to divide by k on both sides. So divide by k, divide by k. As a result, we'll get a over k. K's will cancel. Multiplying k and dividing k cancels, releasing the 2b plus 3c. Okay. Now, 2 more steps. We have to get rid of the adding 3c and the multiplying 2. First, we're going to get rid of the adding 3c by putting in subtracting 3c here. And then when we go on one side, so again, we cannot put these 2 together, so we put them next to each other. A over k minus 3c equals 2b, and these cancel. Now what's left is a dividing 2. Now if I were to divide 2 over here, it would cancel out. But if I were to divide over here, we get a fraction over another fraction. So a little fraction over another fraction. Usually we don't like to stack fractions. So I'm going to use another method besides the division to get rid of the multiplication. I'm going to use same concept that's called the reciprocal. Reciprocals will also get rid of multiplication and division. So the reciprocal for a 2 is a 1 over 2. So I'm going to 1 over 2 here. And the 1 over 2 cancels, just like divided by 2, and we get the b. The 1 over 2 on this side actually distributes 1 times a gives us a, and 2 times k gives us 2k. Okay. 1 over 2 times 3 gives us, or negative 3, gives us negative 3 over 2 times c. And that's it. And we don't have the multiple fractions here. Okay, this next one is actually the area formula for a trapezoid. A trapezoid has 2 bases, here and here. So the base bases are called B1 and B2. You have to get the size of those. We can add those up. Then we also have to know the height of the trapezoid itself. So here to here, you get a height. And you take the sum of the bases multiplied times the height, which that's what this is, and divide it by 2, and you get the area of the trapezoid. So we're going to solve for B1, or one of the bases. So preserving the integrity of the original problem. We have several things to get rid of. We have an adding B, a multiplying H, and a dividing 2. The adding B, or B2, you cannot touch that because that's in parentheses. So we have to deal with the H and the 2. The H is multiplying, the 2 is dividing. So what I'm going to do to get rid of this is use that same idea of reciprocal instead of using multiplication division. I will use reciprocals. So the reciprocal of H over 2 will be 2 over H. Let's put 2 over H here. So the reciprocal 2 over H and H over 2, they cancel. Leaving behind the B1 plus the B2. Over here, we're going to have, we'll multiply the 2H times A. You notice that A does not have a denominator. We're going to give it a denominator 1. So we can say 2 times A and H times 1. 2 times A gives us 2A. H times 1 gives us 1H. Now we want to get rid of the adding B2. I'm going to use a subtracting B2 from this side and subtracting B2 from this side. Notice again, these are not like terms, so we're going to put these next to each other. So it'll be the 2A over H subtracting B2. This side we have the B1, and the B2s are canceled. So this is 1. Number 6. A to the third power plus B to the third power plus C to the third power equals D to the third power. And we're solving for the A. Okay, we have several things to get rid of in order to isolate for A. We have an adding C to the third power. We have an adding B to the third power. And we have a power of 3. So there's 3 things here we need to get rid of before A is by itself, or should I say A is isolated. Let's preserve the integrity of the problem. And we're going to get rid of the adding B to the third power. And the way that we'll do that is by using subtracting B to the third power. So subtracting B to the third power. And so what we have left is an A to the third power, adding C to the third power. Those are not like terms. That's a D and that's a B. So we'll put them next to each other. So D to the third power here minus B to the third power. Okay, next. We want to get rid of this adding C to the third power. So I'm going to use subtracting C to the third power. And we'll get A to the third power, these cancel. And we have 3 terms here. None of them are like, so we're going to just stack them next to each other. Not stack, but line them next to each other. So B to the third power minus, D to the third power, B to the third power minus C to the third power. Okay. The last thing is to get rid of this cube here. So I'm going to preserve the integrity of that problem there. And write this here. Okay, the way that we get rid of a cube or power is by using a root, the cube root. So the cube root here cancels out with the third power there. So what we do on one side, we do on the other. Put one, hold down everything there. So these two cancel, and we end up with A, and we have the cube root of D to the third power minus B to the third power minus C to the third power. This is a resistance formula. It gives you the method of finding resistance when you're using resistors that are, let's say that's a resistor right there. If you have one resistor here, and then the second resistor there, the wire, you can simply just add the resistance. Add that resistance plus what resistance that has, and they'll all add up, and you'll find out what the overall resistance is. But if your resistors are set up like this, kind of like a railroad track on here. This is your R1, this is your R2. The final resistance is not found by just simply adding the R1 and R2. They're found by using this formula right here. So we're going to use this formula to isolate R1. Okay. Now the first problem that we have is that we have denominators here. So we're going to find the least common denominator. Least common denominator have to have a R in it, big R. It's also going to have an R1. And it's also going to have an R2. So this right here ends up being the least common denominator. We're going to multiply the least common denominator times all these terms. So R1, R2 divided by R is R1, R2 times 1 is R1, R2. Next, R1, R2 divided by R1 would be R2 times 1 is R2. Plus here next. R1, R2 divided by R2 is R1 times 1 is R1. Okay. All right, not bad. So now we need to get rid of several things to get R1 by itself. This entire term here, this is adding R2. And then we need to get rid of this big R right here, so multiplying R to R1. So this has to go first. So we're subtracting R2, another subtracting R2 on this side. As a result, these are not like terms, so we'll put them next to each other. So R1, R2 minus R2. That's going to equal R and R1. Next, we want to get rid of the multiplying R, so we have R1 by itself. So we'll use the dividing R here, and then a dividing R over here. These cancel, and we're left with R1. Over here, nothing cancels, so we have R1, R2 minus R2 all over R.